So let's now understand the data. So here I have loaded a data, and in the environment you can see it's a data.df in which we have 690 observation and 80 variables. That's a huge. So like I'm clicking on this button and you can see we have these so many number of columns. And here you can see this is a numeric, this one is a character type. So you can see the data type of each column here, right? So here you can see in a tabular form. So this one is a ISO alpha. This is basically a country code for the India, and this is a country name. This one is a state name. This one is a district name. So this data is basically a level 3 data in which we have the data for the country, for the state, for the district. And this data is obvious that it's indicating the population of that particular district. So this one is a WHO standard. So like if any country having the PM 2.5 concentration level less than 5 or equal to 5, then that country or state is considered to be safe for air quality. And in the same way, there is a national standard column. So this is a national standard that is set by the country level, and it was set to be 40. So in a country, if the PM 2.5 level is less than 40 or equal to 40, then that country consider having the good quality of air. These are two basically primary parameters that we basically use to compare the data. And here you can see the PM 2.5 data is available from 1998 to 2021, right? And these are the concentration level of PM 2.5. So we will explore the data more, we will go in depth to see how to visualize the data, how to come up with the insights out of this data. And after that we have another column, that's the LLP underscore WHO. This is basically a life loss per person. So this value indicate that if you don't follow the WHO guideline, WHO standard, then the life loss per person would be around 0.26 year. So that was 1998. Like if the air pollution is very high, AQI level is very high, then obviously you were inhaling the bad quality of air that will lead to reduce your life expectancy. For this, data is available till 2015. No, I think not 15. You can click here. So data is available till 2021. So fantastic. So we have all the data with us. So this data is basically indicate that life loss per person. So WHO, they do some kind of calculation based upon the air quality in the country, in a state, in a district, and they come up with that value that if you will not follow the WHO guideline, if standard of PM 2.5 concentration, then your life loss over the year will be around 0.79. That's approximately 1 year loss. Like if you are living 80-year life, if you are inhaling the good quality of air, but if you are not inhaling the air quality that is below the WHO standard or equal to WHO standard, then your life will be lost by 1 year. So I hope you have understood these columns. So let me print the columns names. So for printing the column names, you have to just write the call name and write the data df. So these are the columns that we have in our data frames, right? And again, you can see the structure of the data by using str function. Okay. So you can see the structure, basically that's a character type, numeric type, integer type, all these things are given here. And you can also like print a summary. The summary will give you the quartile, range, mean, median, everything. So let me show you how it's coming out. So this is a summary. So you can see, so country data type is character, name 1 is the character, name 2 is the character. Population, you can see the maximum population is 1 crore 80 lakhs and the minimum is like 10,411. And you can see WHO standard is minimum 5, first quartile is 5. It means that it has the only one value, and that's what it's showing here. And in the same way, the national standard is also having the only one value, that's 40 across all the districts. And in a PM 2.5 1998, you can see the maximum value was 78, minimum value was 5.28. So you can see even the minimum value, that's 5.28, was not able to, not good as per the WHO standard. So you can see in India, we have the concentration level of PM 2.5, that is 5.28. That's the minimum. And even the minimum value is above than the WHO standards. That's the irony here. So let me see the latest one. That's a PM 2021. So you can see the maximum value gone all about to 126, and minimum value is 6.63. So this indicates that every year we are not improving. So now let's see how many year is getting lost if you are not following the WHO guidelines. So you can see we have the mean value is around 2.5. So that means that average Indian is losing 2.5 years in their lifetime if they inhale the air quality that was in 1998. So if you compare this 2021, let's see how much we have like increased in the life year loss. So this one is the latest one. So the mean value is, it got increased from 2.5 to 4.5. It got almost twice. And that's a very, very, concerning point for the India. And if you see the number of year is lost in an average Indian is 4.5. Like if you are living a year of life, now you will lose your 5 year in your lifespan and you will live only for 75 years. That's a really a very concerning point, and we have to, like government should come up with some kind of policy to overcome this kind of situations. So let's rename some of the names in a column. So there is a function called rename in dplyr. So you can rename that, like name one is basically a state name, and the strict will for name 2. Yeah. So you can see the name got changed from name 1, name 2 to country, state and district. That's fantastic. And I think everything looks fine. Now it's time to explore the data. So let me filter out the column that has a particular matter PM 2.5 column. So for that, I'm going to use the grapple function. So let's see how we can use the grapple. So grapple, so here you have to provide a pattern that we want to find out. So if you see the column's name, you will find the similar pattern, some of the common pattern, that's a PM. PM is written everywhere if you see. So if I pass here PM and then data frame. So let me see what are argument that I can pass here. So we can say that ignore the case first thing. We can provide the vector column that you want to filter. So I want to filter from call name data df. So if you run this particular code, so you will find all the names of the column. So I want out of all the column, those columns which have PM pattern in the column. So if I run this code now, so you can see, then it will give you the index value. So at a 9th value, a 10th, 11th, these are the index value. And by using this index value, you can grab the column's name of that particular data frame. So I'm here writing as a pollution year. And what we basically want to calculate? So we want to calculate the population weighted pollution. Population weighted pollution all the years. So what does it mean? So it means that we are trying to calculate the average pollution level experienced by the people. So not just the land area. So it will give you the more accurate picture of how air pollution impact the public health, because it accounts for where the people actually live. So I hope I'm clear. If you want to be on the more clear about this concept, you can also you can search on the Google. So let's now select all the columns that has a particulate matter. So let me calculate the state level population weighted pollution. So I'm going to write the call name of the data frame as a state level population weighted pollution, and I'm going to use the data frame data.df, and I'm going to do the group by. I'm grouping it by state name. Sorry. And I'm summarizing. So within the summarize function, we will use the formula of weighted average. So there is a function called across. So what we are going to do across all of pollution, across all of pollution year, I want to sum all the year multiply by population, and here we can do na.rm, that's true, and we can divide it by sum of population, and here also we can do na.rm, true. So if there is any value, then we can simply ignore that value by using this particular command. So this is how you will calculate the population average if I run this particular code. So we have got 37 states, and the average value also we have got. So these are the average value. Oh, I think there's an issue with LLPWHO, how this data is coming here. So yeah, so if you keep the value equal to, you will get the exact value instead of getting a index value, because it's sometimes become confusing. Extract the column name using the index value. So I think it's better to use the values equal to true within the grapple function, so that you can get all the values in their actual name. So this is all the data that we want. So again, I'm going to run this code again. So state. So yeah. So now it's coming perfectly. All right. So if you don't understand, if you're not able to understand this, so there's one more way to do that. So I will show you how to do that. Second way. So basically I'm going to like state label population 2 and keep the data VF here. Again, do the group by, that will be same. State name, then within the summarize. So what we have to do basically, we have to find the weighted average, right? Across all the pollution year. So what we can do, so in the data you can see we have the state name, and in state name there are 3 districts are there in this data set, and in all the districts these are the number of populations, and so if you will multiply this population with this value, and this population with this value, so you will get the nominator, and if you divide it by this population plus this population in a denominator, you will get the average value of that particular state. So you have to do the same thing for these 3 columns. So you will get a one column that will give you the average population weighted pollution value. So let's see how we can do that. PM 2 1998 average, and then like sun PM 1998 multiply by population, right? And then divided by the sum population. So like, oh, sorry. instead of dollars, and you have to write this start, that is basically multiply. So you can see we have got the PM 1998 with 13.5, and if you go to the previous data set, that's also 13.5. So, but you have to do the manually for each of the columns in a similar way. Like you have to do copy this code, paste it here, and like 99, keep it 99, and then again run this code. So you have to mention this manually one by one for each columns. So you can see we have now two columns here, 90, 99 average. So to avoid this, we have used across function. All of this dot is basically is all. So what we want to do, we want to apply this formula to all the columns of this pollution here. So I hope you have understood how this particular code is coming out.